let's have a look at the last question in this paper. So this is a moments question. Let's have a look. Figure 5 shows a uniform rod AB of mass M and length 2A. So if it's uniform, that means the center of mass should be right in the middle. So mg. And then the rod has its end A on a rough horizontal ground. So if it's a rough horizontal ground, we label the normal reaction first, so RA. And if there's a friction, it has to be go to the other side because the ladder should be, if there's no other force acting on it, the ladder should be about to slide down, then the friction has to be to the other side. And then the rod rests in equilibrium against a small, smooth, fixed horizontal peg P. So if it's if it's smooth, that means no friction. So there's only one normal reaction perpendicular to the plane. So let's just label it RP. And then the point C on the rod where AC is 1.5A is the point of contact between the rod and the peg. Okay, the rod is at an angle theta to the ground, where tan theta equal to 4/3. So again, we can just draw a little triangle. So theta is here, opposite is 4, adjacent is 3, so hypotenuse is 5. So that means sine theta equal to 4/5, and then cos theta is equal to 3/5. And then the rod lies in a vertical plane perpendicular to the peg. The magnitude of the normal reaction of the peg on the rod at C is S. So they name this one S. So let me change that into S. And they show that S equal to 2/5 mg. So always do the same thing, just take moments about point A. Then we can ignore RA and friction because they are on the same line as point A. So the only two forces we need to consider is just mg, the weight, and S, the normal reaction. So because it's in equilibrium, that means clockwise equal to anti-clockwise. So to set up the equation, that would be mg times by its shorter distance. So since we take moments from A, the shorter distance from point A to mg will be this length, because shorter distance is a perpendicular distance. And since this is a uniform rod, and length 2A, that means this length will only be A. And because this one is the adjacent, so it should be A times by cos theta. And that should be equal to S times by the shorter distance. So we're start from A, the shorter distance is the perpendicular distance. So since S is perpendicular to AB, so the perpendicular distance is just AC, which is 1.5A. So now we just have to rearrange them. So divide by A for both sides. So then S is just equal to mg cos theta divided by 1.5. And then we know what cos theta is. Cos theta is equal to 3/5. So mg times by 3/5 divided by 1.5. So we know 3/5 divided by 1.5, that's just 2/5. So that's just equal to 2/5 mg, which is what we need for part A. 6 marks. And then the coefficient of friction between the rod and the rod is mu. Given that the rod is in limiting equilibrium, we find the value of mu. So because it is in limiting equilibrium, so that means friction has to be equal to mu r. So let me change that. So mu r a. So and then we can resolve everything either in the vertical direction or the horizontal direction because we only have 4 forces. So 3 of them is either in the vertical or horizontal direction. Only S is not. So resolve S will make everything easier. So 1 vertical, 1 horizontal. So this one is theta. So this has to be S of cos theta. And then that one is the opposite, so it has to be S sine theta. So same thing as always, up equal to down, left equal to right. So force goes up, RA, and also S cos theta. And then force goes down is equal to mg. So that's our first equation. And then second equation is just right is equal to left. So now we just have to simplify. So RA plus S is equal to 2 over 5 mg. And then cos theta is 3 over 5. And then that's equal to mg. So that means RA plus 6 over 25 mg is equal to mg. Because 2 over 5 times 3 over 5, 2 times 3 is 6, 5 times 5, 25. And then RA is just equal to mg minus 6 over 25 mg. So mg means 1 mg. So 1 minus 6 over 25, that's just 19 over 25 mg. So that's what I is. And then put into this one, so mu times by RA, which is 19 over 25 mg, is equal to S, which we already had before, 2 over 5 mg, times by sine theta, in this case is 4 over 5. So then mu times by 19 over 25, so mg should cancel out on both sides. And that's equal to 8 over 25. So now times by 25 for both sides. So mu should just be 8 divided by 19, which is our final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.